Chemical nomenclature. Naming the formulas of compounds. We begin by talking about three scientific laws that are fundamental to chemistry and the foundation of atomic theory. These were discovered in the 1700s. The first is called the law of constant composition, or the law of definite proportions, or definite composition. This law says that when elements combine to form a compound, they combine in a specific ratio of their atoms. Originally, the law of definite composition was stated in terms of masses of the elements, but today it is framed in terms of the numbers of atoms of each element. The law of multiple proportions tells us that compounds are different, even if made of the same elements. The properties differ significantly, even if the ratios of the elements are the same, like NO2 and N2O4. The law of conservation of mass, when stated in modern terms, says that the same atoms are present after the reaction as were there before the reaction. Chemical formulas are written with the symbols of the elements and subscripts written after the symbol. This number tells the number of atoms of the element in the compound. For molecular compounds, the formula refers to a molecule in which the atoms are bound together strongly so they move as a unit. They usually contain only nonmetals. Ionic compounds are usually made of metals and nonmetals. These compounds are not molecular in nature, but are made of separate, independent ions. The metal forms a positive ion by losing one or more electrons, and the nonmetal forms a negative ion by gaining one or more electrons. Regardless of whether the compound is ionic or molecular, the chemical formula is electrically neutral. When we write the formula of an ionic compound, we need to make sure that the formula is electrically neutral. We must, therefore, have a cation, a positive ion, and an anion, a negative ion, in the compound. We use the lowest common multiple of the charges of the two ions to determine how many of each ion we need to have in the compound. The lowest common multiple is the smallest number that the two charges will both divide into evenly. Create subscripts for each ion that take the total charge to the lowest common multiple, and reduce the subscripts to the lowest whole number ratio if they are not already. For example, suppose we want the formula of the compound aluminum sulfide. The aluminum ion has a charge of 3+, and the sulfide ion has a charge of 2-. The lowest common multiple of 2 and 3 is 6. So we need 2 aluminum ions and 3 sulfide ions to have a neutral compound. So the formula is Al2S3. The positive ion is always written first and the negative ion last. Before continuing, make sure you have a table of ions available. The tables shown are from your textbook and should be memorized. Here is the table of common cations. Here is a table of common anions. To name ionic compounds, simply write the name of the positive ion followed by the name of the negative ion. The names of positive ions are usually simply the name of the metal atom. If necessary, we identify the charge of the positive ion with a Roman numeral that is part of the name of the ion. For example, Fe2+ is called iron 2. The names of negative ions are more complicated. The names of monatomic anions are the name of the element with the ending changed to IDE. For example, O2- is called oxide. Polyatomic ions usually contain oxygen, though there are a few that are combinations of other elements like Cn-, the cyanide ion. The number of oxygen atoms determines the ending and a prefix, if applicable, of the anion's name. The most common ion has the ending ATE with no prefix. However, there is no specific number of oxygen atoms that this ending represents, so you will need to remember how many oxygens the common ones have. This table gives a handy memory helper that is tied to the periodic table. You can print this out from Moodle. This section of the periodic table is a 4x4 block on the right-hand side. The number in the lower right of each box is the number of oxygen atoms in the ATE ion. The elements on the inner part of the square take 4 oxygen atoms. The ones on the outer part of the square take 3. The number in the upper left of the square is the charge of the ion. It is always negative. Note that we start from the right with 1 and increase as we go to the left. We ignore the F and O in the first row. While some elements have only one oxyanion, like carbonate, others have more than one. When there are 2 oxyanions, the one with more oxygen atoms has the ATE ending, and the one with fewer oxygen atoms has the ending ITE. When we have more than 2 oxyanions, the foundation is still the ATE ion, which has the second most oxygen atoms. The ITE ion still has 1 less oxygen than the ATE ion. The prefix hypo is added to the ending ITE for the ion with 2 fewer oxygen atoms than the ATE ion. And the prefix per, PER, is added to the ending ATE for the ion with 1 more oxygen than the ATE ion. This table summarizes these patterns and is available for download from Moodle. An acid is a compound made from an anion and the H+ or hydrogen cation. The names of acids are derived from the names of the anions they are made from. If the anion has the ending IDE, the acid name adds the prefix hydro and changes the ending to IC. For example, HCl, made from the chloride ion, is called hydrochloric acid. HBr is hydrobromic acid, and HI is hydroiodic acid. If the anion has the ending ATE, the ending is changed to IC. Any prefix that the anion had is retained. For example, HClO3 is chloric acid, and HClO4 is perchloric acid. If the anion has the ending ITE, the ending is changed to OUS. Any prefix that the anion had is retained. For example, HClO2 is called chlorous acid, and HClO is hypochlorous acid. For binary molecular compounds between two nonmetals, since there are often several compounds with these same two elements, we need the name to specify the number of atoms of each element present. Prefixes are used to do this. The prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca for the numbers 1 through 10. The less electronegative element is usually placed first and retains its name. The prefix is attached to the name of the element. The prefix mono is not used with the first element. The more electronegative element is listed second and has its ending changed to IDE. So we have carbon dioxide and carbon tetrachloride. If the prefix ends with an A or an O, and the name of the element begins with a vowel, the A or O of the prefix is dropped to make the name sound better. Like N2O5, dinitrogen pentoxide, rather than pentaoxide. As another example, the compound P4O10 would be called tetraphosphorus decoxide.